Let's do some homework problems, some extra problems, because either you just love watching math or you might have some questions. Let's do 24. Find the exact value, if possible, without a calculator, and if you can't get an exact value, let me know why. In this one, the inverse sine of the cosine of pi. So, again, we had that. We're just going to do it one by one. Inverse sine, well, what's the cosine of pi? Well, let's look at that. Pi is 180 degrees. Oh, this is one of those weird ones. This is a quadrantal angle, an angle that lies on the edge of one of the quadrants. So for this one, we're going to look at the unit circle. This is the point on the unit circle, -1, comma 0, and cosine on the unit circle is the x-coordinate. What is the x-coordinate on the unit circle here? The answer is -1. So, look at the range of arcsine. The range of arcsine is -pi/2 to +pi/2. And what we have to do is we have to say, okay, what angle is going to give us a ratio of -1? Right? Sine of what angle is going to give us a ratio of -1 in this interval? Well, again, this is going to be also a quadrantal angle, so we have to, again, say sine is the y value on the unit circle. So y value of unit circle is going to be down here. What angle gives that to us? 3pi/2, 270 degrees. But that's not in the range of arcsine. That's going to be -pi/2. You can check your answer with the calculator, but that is what you're going to get. All right. Let's look at number 38. So scrolling down to not that far. Scrolling down to number 38. Find the exact value with the help of reference triangles. Oh, yeah, another one of these ones. The sine of arc cosine, or inverse cosine, of, oh, don't do this to me. I still have just never figured out exactly what's causing this. Of 1 minus x. So again, we're going to use that method where the arc cosine spits out an angle. Arc cosine takes in a ratio, spits out an angle. So we go off to the side and say the cosine of some angle is going to be 1 minus x divided by 1. We don't have to divide by 1, but I like dividing by 1 because cosine is adjacent over the hypotenuse, and this helps me visualize it as a ratio. We don't know what quadrant it's going to be in, but it turns out not to matter for the same reasons that we talked about in 8.3.5. So let's just draw it in the first quadrant. Okay. We have some triangle in the first quadrant whose cosine is 1 minus x divided by 1. I don't know how big this triangle is. Maybe it's twice as big. Maybe it's half as big. Maybe the sides are 5 times as big. But we only care about ratios for trig. So for purposes of ratios, porpoises, no dolphins here. For purposes of ratios, this is sufficient. Well, we need to find y, or b. You can call it whatever you want. A squared plus b squared equals c squared. Solve for y. So we need to subtract this over. We're going to get y squared is equal to 1 minus x squared. And we need to simplify. So off to the side real quick. We're already off to the side. Off to the second side. Right? We need to FOIL out 1 minus x squared. That's 1 minus x times 1 minus x. First, outer, inner, last. That's what FOIL means. First, outer, inner, last. There's also a shortcut, but either way, it's going to be 1 minus 2x plus x squared when you simplify it all out. Let me know if you have questions about that. We're going to get 1 minus what we just found. Make sure to distribute that negative. 1 minus 1 cancels. We're going to get 2x minus x squared. 2x becomes positive, x squared becomes negative. And remember, this is all equal to y squared. So y is going to be the square root of 2x minus x squared, and this can't be simplified at all. We don't know what x is, but whatever x is, that'll tell us what y has to be. Again, this is just going to equal the sine of that angle, which is why we needed y, because the sine of that angle was 2x minus x squared in a square root. Sine of that angle is opposite over hypotenuse. That's just going to be the square root of 2x minus x squared divided by 1. We don't have to write the divided by 1. That's our answer here. And so it's a little hard to check our answer here because we have x's. But if you wanted, you could just plug in some values for x and see if it checks out. Specifically, watch this. I'm going to blow your mind. I might not, actually. You might not be very impressed. But watch this. The sine of arc cosine of 1 minus x. I haven't tested this either. I don't know if this will work. It won't blow your mind if it doesn't work. I told you that this is the same thing as the square root of 2x minus x squared. Oh! Look at that! It's the same thing! Ah, so we can check our answers. These two things are the same thing. And again, I usually crop this window, but this is what I'm actually doing. You can click on this to toggle the green graph off or on. It's the same thing. That's cool. I've actually never done that before in a trig class. Just spur of the moment decision. Thank you guys. I'm going to use that again. Neat. That's how you do this problem. Cool. Math is fun, right? Is it just me? It might be me. Anyway, let's do number 44 next. Okay, this is a weird one. Don't worry, it's not 42. I don't think I made you do 42. If I did, tell me. 44 is secant of t. Evaluate secant of t given that sine of t is x over x plus 1. All right. I haven't looked at this problem. I just thought it'd be fun. So we're going to show you my problem solving skills because I've never seen this problem before in my life. So we need to find secant of t. So first off, it's going to be probably easier if we write secant of t is 1 over cosine of t. You do not have to do this. But I'm very good at knowing SOHCAHTOA, but I'm not very good at... Should we do it? What is it called for reciprocal functions? We have SOHCAHTOA for regular trig functions. Right? SOHCAHTOA for regular trig functions. So the cosecant is the hypotenuse divided by the opposite. The secant is the hypotenuse divided by the adjacent. And the cotangent is the adjacent divided by the opposite. Cho sha sao or something. Cho sha shao. There we go. That's the reciprocal functions. I'll copyright that. I'm sure I'm the first person who's ever done this before. Cho sha shao. But if you're not very familiar with sha, knowing that secant is hypotenuse over adjacent, it might be easier to just put things in terms of regular trig functions and not reciprocal functions. Anyway, so we know what sine is. We'd like to know what cosine of that is. Let's draw a picture. I don't know what t is. I don't know where t is. Let's just draw it in the first quadrant. The sine of t, oh, I see. This is like the same as before. The sine of t is x over x plus 1. Okay, we just need to find the cosine of t, so we need to find this a value over here. So just like before, a squared plus b squared equals the hypotenuse squared. Solve for a. Subtract x squared from both sides. FOIL out the right-hand side. It should simplify to x squared plus 2x plus 1. We also subtracted x squared from both sides. And these x squareds are going to cancel. So a should be plus or minus square root of 2x plus 1. In this case, though, I don't think we know whether it's positive or negative. And it might matter here. It actually might matter. It didn't matter earlier because cosine was positive in both of the quadrants that we were looking at, but we don't know what t is. Does it really not tell us what t is? Like, it doesn't tell us what quadrant it's in. Huh. I'm going to leave the plus or minus out for now. We don't actually know whether it's positive or negative. And I'll do some more digging and maybe make a comment by the video, okay? So we need the cosine. Well, this is square root of 2x plus 1. I think there's a lot of requirements about a problem like this that the book is kind of glossing over. I'll gloss them over as well and do some research after the fact. So we're going to get 1 divided by cosine. That's going to be the reciprocal of cosine. And cosine is going to be the square root of 2x plus 1 divided by x plus 1. Yeah, all right, secant would have been easier. We should have just done hypotenuse over adjacent. Hypotenuse over adjacent is this. The book may want you to rationalize the denominator. I don't care. I think rationalizing the denominator here would make it really, really messy. I don't think it'd make it look nicer at all. So I'm not going to rationalize the denominator. There we go. I never rationalize the denominator anyway. Who am I kidding? That's going to be our answer. Yeah, the sign, whether this is positive or negative or has a plus or minus, I'll check that out. But that's how you do these sorts of problems. And I wouldn't worry about it for the homework. Number 54. Real world applications. Oh boy. These ones are not too bad though. Suppose you drive 0.6 miles on a road. As soon as you see that, let's write that down. We're driving on a road. 0.6 miles. Actually, we don't have enough information to write it down yet. 0.6 miles on a road, and the vertical distance is 150 feet. So there's vertical distance. We're actually going uphill. We have a right triangle. The vertical distance is 150 feet. The actual distance on the road, that's that hypotenuse, that's 0.6 miles. And what it's asking is, what is the elevation, angle of elevation of the road? It wants us to find theta. So on first glance, this is just like 8.3.3, solving triangles with inverse trig. But be very careful. There's a problem here. These are not in the same units. We need to convert them to the same units. So 0.6 miles. How do we relate miles to feet? We put miles in the bottom so that they cancel. We have to make sure that this fraction is equal to 1. So 1 mile is 5,280 feet. Let's multiply that out. 0.6 times 5280. That's 3168 feet. All right, the miles canceled out. All that's left is feet. I'm actually just going to erase this here. And now we can say, the sine of theta is the opposite over the hypotenuse. We could simplify if we wanted to, but we don't have to. Theta is going to be the arc sine, the inverse sine, because we're in the first quadrant, right? Because we're looking at an actual physical triangle and not just angles in general. Angles in general, there's infinitely many answers to that. We'll worry about that later. We look at the inverse sine of 150 over 3168, which again could be simplified. We're getting an approximation here. The arc sine 150 divided by 3168 is going to be about 0.0474. Remember, that's in radians. And that's an okay answer, but when we're talking about the physical world, a lot of times degrees are going to be better. So let's convert that to degrees. Multiply by 180, divide by pi. It's going to be about 2.71 degrees. And then if anyone is actually really curious about that, because I think it's interesting, it mentions it in letter 60. A 5% grade means that the road rises 5 feet for every 100 feet of horizontal distance. So if we actually did find horizontal distance here, we could find the grade. There's also a more faster way of converting degrees to grade as well, but I don't want to go too off topic, okay? But the road is going up at about 2.7 degrees. All right, that's all we have to do for this problem. That's all we have to do for this video. Enjoy some math, because I enjoy math, and I'm still really excited about that earlier thing. Have a good one.